Hi and welcome back. Today we're going to be working on a simple form of thumb latch. There are two kinds of thumb latches. This is called a Suffolk latch because the handle and the back plates are all forged out of one piece. The Norfolk latch has everything riveted to a back plate. This latch is made with a 5-inch piece of 3/8 square bar. I'm starting this latch by forging the handle to its final shape, so I need to create offsets that will define the top and bottom portions of the latch. This is the offset for the top section of the latch, so it needs to be twice the size of the offset that I'll be forging at the bottom end of the latch. I need to have enough material to create the slot to hold the thumb piece as well as the bean-shaped cusp. Now that the handle is shaped the way I want, I'm back working at the top of the latch, and this offset defines the cusp portion of the latch from the slotted section of the handle. I'm using the last bit of this heat to mark my punch location that I'm going to need for the next heat. It may seem like a waste of time, but this small depression is going to take all the guesswork out of punching that hole. Being able to set up quickly is really important, especially when you're punching small bars. You can see how the chisel sucks the heat out of the steel, so taking a few extra seconds to line up your chisel at the beginning of this heat would just make punching that much more difficult. The punched hole needs to be shaped with a drift. The thickness of the drift is exactly the same as the thickness of the bar that you're going to be using for the thumb piece. The other face of the drift is just tapered so it'll fit into any size hole that you're punching regardless of the size of the latch that you're making. It'll take a couple of heats to shape the hole. The drift really sucks the heat out of the bar, and that really reduces your working time. Now that the slot for the thumb piece has been forged to shape, you can start working on the bean portion of the latch. Forging a nicely shaped bean takes a bit of practice. I usually break it down into 3 heats. In this heat I'm using the cross beam to forge down the center section of the bean down to about 1/8 of an inch. In the second heat, I'm only going to be concentrating on half of the bean. The edge of the anvil that I'm working on has a really good radius, so that's going to allow me to forge a nice transition from the thicker portion of the bean down to the paper thin edge. In the final heat, I'm just doing exactly the same process to forge the other half of the bean. And this process is repeated exactly to forge the bean at the bottom of the latch. I usually take the time to clean up the forging while the bar is still flat. If I'm doing a number of these, I'll forge them all to this point, clean them up, and then continue the process. The 90-degree bends for the handles are shaped in the vise. I am hammering with my wrong hand here because I can't get a camera over to the other side of this vise. The other end of the handle gets bent exactly the same way, and then the final shaping of the handle is done over the horn. The thumb piece for this latch is forged out of 3/8 round bar. The process is almost identical to forging the handle. I start by creating an offset that's going to give me the material that I need to make the actual thumb piece, and then the rest of the bar is just forged into a flat bar that's going to fit into the slot of the handle. The interior mechanism of this latch consists of 3 pieces. There's the latch bar that locks into the latch plate, which gets mounted on the jamb. And then there's a keeper that controls the travel of the latch bar. To assemble these parts, you're going to need to make a slotting chisel that's exactly the same thickness as the sheet metal that you're using. I would normally hammer out a chisel from a piece of spring steel. It was a long process that took a lot of grinding. But fortunately, as you get a little older, you get a little smarter. And now I just cut them out of these saw blades. This is a perfect example of how necessity is the mother of invention. If I didn't have to make a dozen of these for a class I was teaching, I never would have looked for an easier way of doing this. And these saw blades do come in a wide range of thicknesses that cover just about everything you would need. To cut the slot, you just drill a series of holes that outline the location of the slot, and then you use the chisel to shear out the metal in between the holes. Then you assemble the pieces and use a file to trim the length of the tenons. And then you use a light cross peen to rivet the tenons in place. Once the parts are riveted, you use a file to flatten up the back of the plate. To complete the assembly of the latch, the thumb piece is locked in place with a small rivet through the side. And of course the screw holes will also need to be drilled through all the back plates. Traditionally, the keeper and the latch plate were designed to be driven into solid wood. This approach is designed to accommodate modern-day framing and light-duty doors. But the reality is each situation is a little different, and you really are going to need to be prepared to design whatever is needed for that location. Thanks for watching, and we'll see you next time.